This conference will now be recorded.
Hey, good morning, everyone. Am I audible now?
Yeah, good morning, Graham. Yeah, you're audible.
Thank you. All right. So, thank you so much for joining. Give me a second. I'm going to share my screen. Okay. All right. Again, thanks everyone for joining this course and welcome to this course. We have this is DevOps with AWS. Okay. For those of you who haven't joined the uh, course on demo on Saturday. Just a brief introduction. This is DevOps with AWS, not an AWS specific training. We cover a lot of AWS services as well as we have DevOps as part of our course. So it's all about learning DevOps and how do we implement this in AWS. But as part of that, we are going to learn a lot about AWS services, like how do you use AWS accounts, organizations, what is the IAM, identity and access management, what is a VPC, what is what is storage, how do you create virtual machines on AWS, and how do we use all these things. Okay, understood? So any questions on that? What our course is all about? Yeah, it's not. Uh, It's not a typical AWS course. It is a DevOps course where we are going to do all this on our AWS lab. Okay. So AWS is going to be our platform, our infrastructure platform where we are going to run all this stuff, right? So we are not going to, we don't need to have any home lab, or you don't have to create any virtual machines on your laptop or anything. Everything is going to be running on AWS. So in this process, we are also learning AWS. Why did we choose this way, right? Because here you have to learn, I mean, you're going to learn AWS plus many of the DevOps tools, like what is Terraform, how do we use Terraform, how do we use Ansible, how do we implement this at all using virtual machines, like using EC2 instances, right? So all these things we are going to learn in this um, training. Okay. So again, a brief introduction about myself. Again, for those who have not attended, I'm Kiran. I have about 11 years of experience in platform engineering, DevOps, and SRE. Back in the day, if you go back like 7 6 7 years ago, it was not called as DevOps. It was called as something like IT operations or platform engineering, right? So that's why I would say 11 plus years of experience, but that doesn't mean I was always called as DevOps engineer. The work was almost same, but back then there was not so much of automation and all that stuff. Okay, any questions? All right. So just a brief thing, and how do we proceed? What are my tools that I use while I'm sharing my screen, so that you don't really miss what's happening, because obviously virtual trainings are not always so easy, because there is a lot of context switching, there is some delay, whatnot, right? So I I'm going to, teach from this laptop, which is a Linux laptop, but pretty much familiar UI, nothing different here. Mostly, I'm going to open my. By the way, is everyone able to hear me and follow me? See my screen and everything? Just a quick test.
Yes, sir.
Okay, cool. Um, so I use Firefox as my default browser. I use Chrome just to connect to my GoToMeeting because there is no GoToMeeting app for. Hey, sorry. Uh, what was I saying? Yeah. So I use my Chrome browser only for my GoToMeeting. I use Firefox browser to open my websites. It could be AWS or any documentation or anything I open in Firefox. And because when I'm typing something, when I'm saying something, I might also type here to make the subject clear to you. So I might use my notepad. Here I use a Sublime tool. So where I use it for note taking tool. Okay. And for anything that needs to run any commands like Linux commands, or when I'm accessing a EC2 instance on AWS, I will use my terminal. Okay. Terminal is another tool, just like your command line in your Windows. Okay. You will use a tool called as git bash in your computers to do the same thing. Okay. So let me call it as also my git bash or simply terminal. Terminal is nothing but a command line tool using which we can connect to various different um, you know um, virtual machines. Okay. And I also use Visual Studio Code. Visual Studio Code is a code editor. It's like your Notepad plus plus, like you have Notepad to write your simple note taking tool and all that, right? Visual Studio Code or any of these things are also called as IDEs, integrated development environment, which is used to write code because they have this advanced features of formatting the code and showing it to you in a nice format like this. Okay. Or you can open multiple files at the same time, compare files side by side. So you are also going to install this tool when we come to the coding part. But these are the tools I'm going to predominantly use. All right. So everything we are going to do on a browser and terminal windows. um, and the way I'm going to share the notes is two parts. One, I'm going to share my GitHub repositories where I have put simple text files and all that. And then we have something known as what do you call the Google Drive, where I put some PDF files and other resources that I will share with you. Okay, so this is how I share my notes with you as we go along. Not immediately, but as we go along, I'm going to share the notes. And every day the call is going to be recorded and shared with you. I mean, they will share a Google Drive link to you, so you can access that link. And even if you miss the class, or there was some kind of issue at your home which due to which you were not able to attend a class, that particular recording will be available for you and you can watch it even after the course is over. Also, if you want to review some topics, you can go back to that particular day and watch that video. All right, that is available for you. Okay, that's how we are going to proceed. And the classes are from 8 a.m. to 9 a.m. IST, um, Monday to Friday. All right. So this course is about maybe about 10 weeks, 10 to 11 weeks, based on you know any breaks I might have to take because of any particular reasons, right? It might extend, but mostly we should be completing in 10 weeks. Okay. And the fees details and everything, it will be communicated to you by Lakshmi Garu from Career IT. I mean, they will reach out to you, so that's fine. What are the other things I wanted to talk about? Okay. And I pretty much encourage you to ask me any questions. at any time. You need not wait till the end of the class or at the beginning of the class. Uh, but if it is particularly more personal question like your own career, or general generic question like what is you know not related to that particular topic on that particular day, I would request you to wait till the end of the class and ask questions. Okay. And another thing to note is, I have another batch before this one. So sometimes, like today, I might be a little late by 5 6 minutes. Okay, I would request your patience in that matter, because I don't want to leave a subject uh, in the middle, and that will like kind of mess up the entire class. So sometimes we might also extend a little, like till 9:15 or something like that. But that's fine, I guess. I mean, for the folks in the US, it's going to be a little tough, but mostly we'll try to wind up by 9 o'clock. Okay, questions now. Any questions about our approach?
No, sir.
Okay. All right. Thanks again, everyone, for joining. So, and mostly we might not have so many presentations, all right? Because I believe in, yeah. By the way, I forgot about another tool. It's again a website only. For any kind of illustrations or drawings, I use this tool called as draw.io, where I draw pictures. Not so great, but whatever I know, I generally draw the pictures and explain stuff, so that it makes it easy for you to understand. Okay, you're free to capture the screenshots, no worries. All right. Okay, any other questions before the start of the course? Please go ahead and ask me. If you attended the demo and had some question on that day, couldn't ask, that's fine, you can ask me now. We'll spend the next 2 minutes on any questions. If not, we'll move on to our first topic. And also, by the way, if there are some third-party links, or any kind of documentation from AWS or other sources, I'm going to paste them in your chat window here in GoToMeeting. You can copy them and bookmark them. Okay. And also, I would recommend taking notes, maybe on a physical notebook, like your regular pen and paper. Though if you don't refer that later, if you uh, if you write down on a pen and paper, I would believe it's going to stay with you for longer. But I leave it up to you. It's up to your choice. Okay, how do you want to do it? Okay, right. So the first topic is not basically a topic, but we are going to discuss more about what is IT infrastructure in simple words, right? So let's say you're opening a page called as google.com on your browser, right? Or any page for that matter. So what generally happens? We'll try to come from here and try to understand what actually is the entire process, and from this we are going to learn how the IT infrastructure itself is uh, itself works. Okay, so can someone tell me what happens when you type in Google dot? I mean, I don't want the full explanation, but I want only this one. When I type in google.com and hit enter, and till the time it loads me the google.com page, what happens? From the time I enter the URL and hit enter, and from the time the page is loaded onto my browser, what generally happens? Anyone? See, there are no right or wrong answers. You can definitely feel free to answer. Okay. So let's say this is my browser, and I type in www.google.com in my search bar, or simply google.com. What happens before the page loads? What happens after the page load? We'll discuss later. Come on, folks. There are no, silly answers or wrong answers. You could feel free to answer. Okay, I'll tell you what happens. So computers understand what we call as binary languages, right? Or they understand numbers. In simple words, they understand numbers. They don't know the human language. So the first thing is my browser needs to know where this needs to go. When I say google.com, it needs to know where it has to go to get the required web page. See, when I'm accessing anything on my computer, except a Word document or something which is locally located, okay, most of it is located in someone's computer somewhere, okay, someone's server somewhere in the internet. Okay, that means if I'm accessing google.com, the page that is coming onto my screen is created by someone and stored in someone's computer in some other location, which we call it as a server. But how do my computer know that it has to go to that particular computer to get that web page, right? For this, computers have a thing called as IP address. We are going to expand on the IP address in tomorrow's class, but for now, just understand that my browser first needs a thing called as IP address to know where it should go to get the required details. Okay, IP addresses are typically in the format of this format, like So my browser needs to know this particular address for google.com. Okay, so if my computer has already accessed google.com, my browser might already have it in its cache. Cache is CSCHE. It's a temporary memory remembering the previously done things to get work done easily for you. Let's say I have never accessed google.com. So in your home connection, what is your computer connected to? I mean, not the power charge or not the headphones, but from the networking wise, how are you able to listen to me now? Because your computer is connected to a router. That router is connected to a internet connection, correct? So the next thing your browser is going to do is go where? Router. You all have these things called as router or modems at home, right? Do we all have? Or if you are a mobile user, maybe it's going to the nearest tower. Okay, so ideally in a broadband connection, your request goes to the router. Most routers have this thing called as they could also cache this IP address. So it might have an entry called, okay, if you're looking for google.com, go to this particular IP address. But let's suppose in your home also no one has ever accessed, so the first time you're accessing it. So the next thing it does is, so who gives you internet connection? Who do you call if your internet doesn't work?
ISP provider.
Yeah, internet service provider, or what we call as ISP, right? So it goes to ISP, internet service provider. Who is this internet service provider? It could be Airtel, Tata, or Act Cable, or in case of US, it could be AT&T, Verizon, any of these things, right? Uh, so these people have something called as DNS resolver. What is DNS? We'll talk about in a minute. So this DNS is nothing but it's like a directory. Okay, if you're old enough, you know there is a concept called as telephone directory. Okay, so what does this telephone directory does is it has names of all the people. So I'm talking about back in the 90s when we did not have mobile phones. So everyone used to take connection from BSNL uh, or VSNL. Sometimes there was this VSNL as well. And whenever you take a phone connection, they would register this in a telephone directory. So your name, for example, Kiran, followed by my number, whatever it is. Okay, let's say someone else, Shekhar, number. So it used to have all the entries for all the people who have a landline connection. Okay. So similarly, your DNS is like this. Whenever you create a website, you have to register with a DNS. Let's say you created a new website called as nextgen.com. Okay. Then you have to register the IP address in the DNS record. So this DNS resolver ISP is what it does is every time someone accesses any of the IP addresses, any of the domain names, it will store all the IP addresses locally so that it can serve its customers faster. But sometimes, let's say no one in your region has accessed the google.com website. Okay, just for the sake of it, understand. So now it goes to what is called as a root server. So in order to answer your query, there are multiple organizations that are running servers. Okay, why? Because internet is a widely distributed one with different people maintaining different components of it, right? So when you create a website, let's say when Google has first created its website google.com, they have to get it registered somewhere. Okay, it's called as a domain registrar, and the when you register with a domain registrar, you know, they have different organizations. For example, there is a root server which maintains all the top level servers. What are the top level servers? Like .com, .in, .org. So look at any website, right? What are the common names we have? .com, right? Google.com. The last part after the dot, or google.co.in, or let's say gov.in, right? If it's a US government site, it's going to be simply .gov. And these days we have all kinds of extensions, all kinds of top level domains like .tech, .me, .website, you name it, you have them, right? But previously we used to have very limited number of top level domains like .com, .in, .org, .co.uk for UK specific websites. For educational specific websites, what is the top level domain? .edu, right? So on and so forth. So these are what we call as top level domains. Okay, but to maintain all these top level domains, you have something called as a root server. Okay, so this root server maintains the records of all the top level domains, like .com, .in, .co.in, .gov.in, .org, .edu, .tech, you name them, right? Whenever there is a new top level domain, it's called as top level domain, is introduced, okay, that is stored in your root server. Okay, so your ISP will forward the request to the root servers, and the root server says, okay, I know this belongs to .com top level domain, and I know where it exists. So this will redirect me to what we call as .com's TLD. TLD means top level domain. So here it specifically has the records of only the .com servers. This TLD server, what does TLD means? TLD means
Top level domain.
top level domain. Level domain. This TLD will this has the so whenever someone registers a website like google.com, right? So they will buy from some organization, like if you have to buy a website name today, if you decide to buy a website name, you have to go to a registrar like GoDaddy. I'm talking only about the names, not the website. Just because you have a name, you cannot run the website. You need some other things as well. Okay, let's say you can go to GoDaddy or Namecheap or AWS Route 53. These are various places where you can buy domain names, or Freenom. Okay, so here you can go there and kind of get yourself a new domain, but it depends upon availability, right? You cannot go and register a website called as google.com. Why? Because it's already registered to Google LLC or Google Public Limited or whatever it is, right? So you cannot buy a website called as google.com, but maybe you might try for googly.com. Googly.com is also over. Maybe mygoogly.com, whatever it is. Okay. So when you buy a website, you go to one of these people, one of these organizations like GoDaddy, Namecheap, or AWS Route 53, and you have to pay some yearly fees. They say, okay, for the first year, we're giving it for only $5, take it up. So you buy, let's say, mygoogly.com from Namecheap. So Namecheap has to update this information to the top level domain, saying that, okay, so and so person has bought this domain name. So now from me, so now the top level domain will send it to the registrar. Okay, who is a registrar? A company who sells the domain names. Okay. what's happening. So the request will be sent forward to what we call a domain registrar. Okay, like you might have seen a lot of ads about GoDaddy, right, on TV also. So what they do is sell the domain names. So your request would be forwarded to domain registrar. So here, when you buy a website and start making it working, you might have a load balancer. You might have an IP address. Let's say you will say my IP address is 20.18. So you will say that my nextgen.com, let's say it's nextgen or google.com. Google.com is available at 103.10.20.18. Okay, so this is how your computer now this domain registrar is going to send back to the top level domain. So your top level domain also caches it in the sense it stores it locally, then it sends to your root server. From the root server it comes to your ISP also caches. Everyone caches at every location, so that next time another request comes, it need not go all this way here, but it will live here, and from here it will go to your router, and from here it comes to your browser. Okay, but what if tomorrow my IP address is changed and this is updated to, let's say, 103.101.201.202. Let's say 118, whatever. Okay, then how does these people will have stale IP addresses, right? No, what you can do is there is something called as TTL, time to live. Okay, in a DNS setting, you can also put something called as TTL, time to live, which tells the DNS to refresh every so and so seconds. You could put for every 24 hours. So every 24 hours, all these things which have already cached will again query this and it will get the latest IP address. So that is also possible. So this is how you're going to get only the IP address. This is not the web page. You're only getting the IP address in order to go to some other location. Okay, that is this location. There might be some web pages running on a web server or a computer which is there with this IP address. What is an IP address? IP address is simply a location of a particular resource on the internet. Okay, it's like you could say to find homes you have door numbers. To find to talk to people over phone you have phone numbers. So a domain name is simply like a phone number for a website. Okay, it will send you to the location where your website is hosted or website files are located, so that it can grab those get those files and show it on your browser. Make sense? So what do we call this? This is an IP address. Okay, but the the directory which shows these things is called as a DNS server, domain name server service or server. Okay, domain name service, DNS. IP stands for internet protocol. What that means we'll discuss tomorrow. All this while what your system has done is only get the IP address. Once this IP address is there, now your browser will go to this location. Okay, wherever it is located to. You might ask, now how do my computer know that it has to go to a particular DNS server? That is also already preloaded on your laptops. Most of the laptops, every laptop has a DNS settings. Okay, it knows that it has to go to that particular IP address to grab it. Or in fact, you anyways go through your router, so your router will go through your ISP. Okay, even if it's a mobile data connection, it works the same way. Instead of router, you might have a tower. From tower, it goes to your Airtel office. Airtel also has a DNS resolver, and it will send it to root server and the particular top level. The same thing works. Nothing much changes. What if it's a mobile app? Mobile app also has an IP address. Your mobile app is nothing but a glorified browser which will hide away all the URL and other things, right? For example, what is WhatsApp? WhatsApp is also like a website only, but you will not see the URL, you don't see the refresh options and all that. It is customized to show you only the chats and other things. Okay, it has better functionalities, but only specific to WhatsApp. But a browser is a generic thing. You can access multiple applications. Everyone, even if it's a mobile app, unless it's a local app which doesn't have to interact with any other service, let's say something like a word editor, um, or a notepad tool, or whatever that is running locally, if there is an app that has to communicate with internet, something like YouTube, something like WhatsApp, something like let's say IRCTC mobile app, everything also has to do the DNS resolution at the back end, but you don't see all those things. Of course, even in the case of a browser also, we don't see all these things, but what we see is we enter an IP address and a page is loading on this one. Okay, so all this way you'll go here and get the IP address. Sometimes Google decides, okay, or whatever organization decides, I want to maintain my own IP address in my own DNS servers, right? So then they might create their own DNS servers. Here they still have to say where your DNS servers are located, right? So here, because Google has a lot of subdomains as well, right? It has google.com, drive.google.com, mail.google.com, a lot of other things, right? So they decide to maintain their own DNS, but they still need to tell where the DNS servers are located to your registrar. These are called as name servers. So you update the name servers from here to here. So your domain registrar will send those requests to the following DNS servers. Okay. So this is also possible. And trust me, we are going to do all this in practice. Not all these things, because we don't have to set up all these things, but we are going to create our own website. I already have one website. I'll show you how to update the IP address, or how to update our own DNS servers using Route 53. We will use Route 53, which is an inbuilt service in AWS, to do this thing. Okay, not immediately. Don't worry, not immediately. We'll take some time to do this. But first, I want you to understand what happens in a typical um, when you're accessing an application. All right, so you got your IP address. Now your browser knows where to go. Again, the path will be same. It goes through your router and through your ISP. But for just for simplicity, I'll skip those steps, and let's say your request is going directly to a particular computer, which is I'll call it a server. Server is nothing but a computer. Okay. So let's say this request has to go to a server in the Google's data center, where Google has all its infrastructure, right? So you remember we talked about physical servers in the demo also. So these are like your computer desktops, but in a large scale. They have more CPU, more RAM, more capacity to take load and all that stuff, right? So your request will go to this particular physical machine. Okay, let's suppose there is only one physical machine. This is not what it happens, but let's suppose it goes to one particular machine which has the IP address of whatever we thought earlier, right? Like, let's say this is the IP address 103 dot whatever. Okay, so this is the IP address that is gotten from all these steps. Now your browser will go to this particular um, server, right? So this server, see how many users access Google at any given time? Millions of users, right? If not more. So that means every time someone accesses a web page from google.com, you're initiating some processes inside this server. That means the more number of users are accessing the web page, the more load it takes. Okay, that means it needs to be very powerful computer. Maybe what does our computers have in terms of RAM and CPU? How much CPU and how much RAM does our computers have? On your computer, how much RAM do you think you have?
4 GB.
8 GB,
4 GB.
60.
And how about CPUs, processors? Maybe if you talk about i3, it might be a quad core, 4 cores, each with a speed of 2.3 gigahertz per gigahertz, right? Something like this. Or look at, I think most of you know about your mobile phones. Most of you might have 8 GB RAM, and let's say a Qualcomm Snapdragon octa core or something, which means you have 8 cores. Each core has this cycle speed, right? But let's say because Google needs to serve hundreds of thousands of customers, let's say they have uh, 1 petabyte of RAM, and let's say 4096 CPUs. Okay, each of them, let's say, is at 3.5 megahertz gigahertz speed, right? Very high powerful computers and all these things. Okay, let's say this is the configuration of your this particular server. Let's say only one server is serving the request for all the users. Okay, so very powerful, super powerful, with as I said, 1 petabyte. Petabyte is how much? 1024 terabytes. And 1 terabyte is how much? 1024 gigabytes, right? and let's say 4096 cores. So it's very super powerful. So no matter how many users are coming it will accept the load and serve the request. But the problem is, in the world of information technology, IT, your systems are always prone for failures. They could fail due to multiple reasons. It doesn't matter how powerful your computer or how weak your computer, there could be some glitch in the network, there could be some software issue or some hardware issue due to which this one system might not work. Let's suppose this system crashes. Okay, then what happens? Let's say google.com is accessible only through this one server. Then what happens?
Load will
All the
affect.
No one will be able to access google.com. So how do we make sure this doesn't happen? How does Google today make sure that this doesn't happen? Again, I'm telling you, it doesn't matter how powerful your computer is, IT infrastructure is always going to go through some kind of failures, right? So what can we do? So what we can do is we can create a secondary server with the same kind of setup, same operating system, same files running. All the things are there. It is what we called as a redundant server, secondary server. For example, it could be, it may not be 1 petabyte, maybe 512 terabyte, and instead of 4096, the smallest 204. Okay, so two systems with the same configuration, same software, everything is same in both the systems. But this has one IP address and this has another IP address. Now, which IP address will you update in the DNS server? Because DNS server is a typical key value pair. It will accept only one value for one answer, one domain name, right? So what can you do in that case? If you put this IP address, all the requests will go to this one. If this one fails, this one is running, but no one can access this. Then again, you have to make the change in DNS server. So how can you mitigate this? So to do this, think about a bank situation where you have multiple cashiers, but these days we have something called as token system, right? They will issue a token to you to wait for count. I mean, once your turn comes, they will tell you to which counter to go. Similarly, in the computing world also, you have something called as, or like a receptionist at a bank, you have something called as a load balancer. Okay, so this load balancer could be a physical device like your router. What this does is it takes the request from end users, and from here it will redirect to one of these VMs. Okay, so in the DNS name, you're not going to update the IP address of either of these machines, but let's say you're going to update the IP address of this load balancer. So when your browser gets the IP address, it is not going into one of the servers, but it is going into the load balancer. What the load balancer is also a small computer kind of thing. Your router, for example, it's also a computer. It has an operating system, but we don't call it as OS. We call it as firmware. Okay. If you go to your router, if you're connected to your router and if you access 192.168.0.1 or 1.1, either of these IP addresses, you will see your router's homepage also, just like a you can also manage your router. It is also a computing device. Similarly, a load balancer is also like a mini computer. It has a very limited functionality. The functionality is to receive requests from the end users and send it to one of the target servers. Okay. In this way, what you're doing is achieving high availability. Okay. So you're achieving high availability by running two different servers which are front-ended by a load balancer. Okay. So for, let's say, due to some failure, this system is down. So still your users will be able to receive web pages from this particular server. So in the meanwhile, what will Google engineers do is they will fix this server and both of them will be again ready. Okay. So maybe not two, maybe three, maybe four, maybe five, because more the backup, more better it is, right? The better it is. So you could have as many VMs as or as many physical servers as possible in your setup, and all of them running the same kind of software, same kind of web files. Everything is same inside these things. Okay. So this is how you achieve this high availability. But think about this, right? Think about this. When you access a web page, it will show you what we call as a HTML page. For example, when you go to google.com, it shows you something known as an HTML page. This is written in a language called as HTML, and some images uploaded, and this HTML knows to show that. But when we start typing something like, IT architecture, for instance, so when you type this one, it has to get details from somewhere from Google, right? It has to get these details from somewhere. So that means not only the web server. So the software which can show you the web pages is known as a web server software. For example, you have tools like Apache. I mean, we don't install on our local machines. It is installed on the servers from which you are accessing your web pages, or Apache, or Nginx, or IIS for Microsoft Windows. You have something like PHP, Tomcat, different kinds of servers which will show you web pages. Mostly these three. Okay. Uh, so these are one kind of software, and to store data and to retrieve data, you need another kind of software called as database. Right? You heard about databases? MySQL. Anyone heard about MySQL? No? Not at least once? MySQL, Microsoft SQL Server, Postgres. All these are
No,
different
sir.
kind of database. All these are different kinds of database softwares. So in order to show you the web pages and store these web pages, Google also has to run your web server. Let's say it's using Apache, and to store your databases, it is using MySQL Server. Okay, so just like how you are installing Chrome and also Firefox on the same server, on the same laptop, and also some Notepad tool, some other tools on your some VLC player, you could install both Apache and MySQL on the same set of servers. Okay, going back to this image, where is this? Yeah, this could run both Apache software as well as MySQL. But with the experience, people have identified that, okay, if you run two different softwares, particularly when they are accessible for end users, okay, there is a chance that due to failure in one system, the other one is also causing failure. Maybe due to software issue, MySQL is taking up a lot of data, a lot of RAM. Okay, that means now Apache is running short of storage. See, we have three machines. That doesn't mean we'll take it easy that even if one machine is running, it's okay. No, you have to make sure all the time all the three machines are running. Otherwise, it's going to cause some other issues again, right? So let's say you're installing Apache plus MySQL on the same server. What happens is it might lead to some kind of issues because MySQL might be taking up all the memory and Apache has no memory. So that's what then from the experience, what computers engineers have recommended is whenever you're running two different softwares, make sure they're running on different servers, particularly in the enterprise grade when you're exposing these applications to end users. So what you need to do is again, okay, you need to make sure here only Apache is running and MySQL is running in different set of servers. Maybe here only MySQL is running. Sorry. Okay. So in order to communicate to these machines, maybe there is something like another load balancer internally. So these, because you need to know a single, even the computer, if it has to communicate with other computers, it needs to know the IP address, right? Even computers connect with other computers using IP addresses only. So how do you make sure these things can communicate with each other? You might have an internal load balancer. So these machines will have that thing in their code, say that if you have to get any details from database, go to this particular IP address. That IP address might be of a load balancer. This load balancer in turn, will send the request to one of these VMs, one of these servers, not VMs. Okay. So here we have three different layers. One is the presentation layer on your browser, which is showing the web pages, right? And the other one is your application where it is actually hosted, and another one is the database where your data is actually stored. Okay, so this kind of setup is called as a three-tier architecture. What is it called as? Three-tier architecture. Okay, so you have a presentation layer, you have an application layer, or you have a data layer where the data is stored. Okay, sometimes this three-tier architecture might also have another layer in between. For example, when I search for something on Google, do you and I get the same results? From your experience, when you access google.com and search for something, do you and your friend get the same results? No, right? Because Google has this algorithm. After years of stealing our data, Google knows what I am more interested in, what you are more interested in. For example, if you are looking for something like a um, some product to buy, let's say computer or a laptop. So Google already has data about uh, what my interests are. I'm into more of DevOps, technical stuff. So maybe it will suggest something like a higher end configuration. But maybe let's say you are a graphic designer, you are more interested in designing graphics or paint and all that stuff. Maybe Google will recommend MacBook for you. Okay, just an example. Or let's suppose Amazon.com. Okay, Amazon.in, it might recommend you MacBook based on your previous behavior, previous purchases, because you are a graphics designer. MacBook is much better for you. For me, it might recommend something like a ThinkPad because I'm more into, you know, not aesthetics, but more into technical stuff, right? So when I say Google, it's not a person who is doing this thing, right? Or Amazon.com. It's again another computer which does this logical calculation. Okay, based on this person's previous history, I'll show him only these kind of recommendations. For this, you need something called as a business logic working, some kind of software application that will process your logic, that will process the logic and give you the recommendation. Okay, let's say, or another example could be, take banking applications, right? These days if you have to apply for a loan, it has become quite easy. You don't have to um, go to a bank and apply, right? You can go to your mobile banking website and simply give all the details, and it's going to show you all the um, loans available for you or the offers available for you. Okay, how is this thing happening? Through what we call some kind of business processing is happening at the back end, right? It is going to check your previous history. It is going to query some details from your CIBIL and all that, and after that it is going to show you these results. So for this, you might have additional computers which are running a specific software made only to do this business processing. Okay, this is what we call as application layer. Okay, so you have your web layer, your application layer, and your database layer. All these things together could be called as your three-tier architecture. Okay, each of the computers is performing a certain role. Okay, each of these computers is performing a certain role. The web servers are showing you the web pages. The application servers are processing the data. Who is the logged in user? What is his past behavior? For example, if it's google.com, if it's a banking site, based on the authentication details you provided, it will fetch the database details and see how much. Let's say you're doing a net banking transfer, right? So this application server has to do all the computation. It has to check how much balance is there from the database. Then once the transaction is done, it will update the database saying that, okay, this person has transferred 10,000, so reduce 10,000 from his savings account. And all these things are done by your application server. Whereas your web server is only presenting the web pages. It receives the data from your application server and show it to you on a neatly formatted HTML page in the front end. Okay, so if you have to, let me open a new window and let me put it in a neat format, or what I think is neat format. So if you look at the applications when you're accessing today, it could be WhatsApp, YouTube, any other application, right? These things are common. So you have what we call a, so you have a bunch of web servers, which are going to show you the, so your request is directly always going to the load balancer, which can show you the web pages, the web servers, right? And then these web servers are going to contact your application servers to understand about you. See, web servers are simply presentation layer. They only present whatever data your application server or your database is going to give. Okay. So, and for each of these layer to communicate with the other layer, we have what we call as a load balancer, correct? So at each layer, there might be something known as a load balancer. This is like a gateway, like, for one set of servers to communicate with another servers, or for end users to communicate. This is like a single point. So end users will communicate to the load balancer. This load balancer will communicate with your web servers. Okay. Sometimes your web servers might directly contact your DB servers. Sometimes they might go through the application server. It all depends upon what kind of transaction you're doing and how the system is configured also.